All right, peace. What it is. All right, lastly, I left off with my guy right here, and he was explaining the strong force of the standard model, and I was just presenting my um critiques of it. Hey, who am I to say? I could have said the dude's in the Illuminati and he's telling lies. And Einstein was in the Illuminati with 666. Blah blah blah. I ain't going down that route because what's the point? Some of these people just doing what they believe is right. You know what I'm saying? This is just to be cool. So anyway, like I said, I'm just gonna present to you a alternative theory from the book Future Science. Okay, so this is chapter one, and essentially what I left off with in my last video was how their explanation for the strong force don't really work when you consider that the particles had to become within close proximity of each other for the strong force to take hold. And if they came about from the Big Bang and the magnetic force is keeping them apart because they're identical particles, then how did they ever get close enough to create, the helium atom in itself? So essentially, in this chapter, that's where I got this idea from. It's from this book. Okay, so I'm gonna let him. I'm reading the book here, and you may get a better understanding from the way he presents it than I did. It's where I got the idea from. All right, so let's go. Chapter one: The Secrets of Gravity. A new way of thinking. If you had the chance to design your very own universe, how would you stop the billions of new particles from flying around all over the place? One way would be to make every particle attract every other particle, because that way, sooner or later, all particles will group together into large accretion like boulders, planets, and stars. So how would your force of attraction work? In 1687, Isaac Newton defined gravity as the force of attraction between two bodies. Although he never understood what caused it, how it worked, or where it came from, he could never have imagined that his carefully chosen definition would help deny for centuries an understanding of how gravity actually works, because it fails to recognize a moment in time when only one body existed. Alright, so you see, he's setting up the logic. If gravity is a force between two bodies, right? That's the definition. Then what was gravity when there was only one particle, like the hydrogen atom? And that's his premise for this mental exercise when he goes to prove the rest of his point. So let's keep going. If we are to understand how gravity works and succeed where others have failed, then, as Emmanuel, that last name, points out, we need to begin where others pass by and sure of their way. So our journey begins at the very beginning. At the very moment one body must have appeared, figure 2I, before any others. To be clear, the Oxford Dictionary defines body as, among other things, a quantity of matter, and the known smallest quantity of matter is the atom. And for the avoidance of doubt, quantity is further defined as a number of things, plural. The creation of that first atom must then have been followed by the creation of a second, then a third, and so on. And here lies the crux of the matter. At the time the first atom appeared, according to Newton, there could have been no gravity because there was only one atom. Now consider the moment when the second atom appeared. At that moment, if we agree with Newton, the first atom is attracted to the second, and the second is attracted to the first. This means that during the time interval between the creation of the first atom and the second, figure 2I, some force must have traveled from atom 1 to act upon atom 2, pulling atom 2 towards itself in the same way. Some force from atom 2 must have traveled to atom 1, pulling atom 1 towards itself. This seemingly innocuous observation reveals one of the qualities of gravity that others have failed to appreciate. The gravitational force, whatever it is, must travel. So what could atom 1 be sending out to attract atom 2? And what could atom 2 be sending out to attract atom 1? There are only two known states of being in our universe, matter and energy. Each atom therefore can send out either only matter or energy or both. In order to send out matter, atom 1 would have to disintegrate and send out bits of itself to travel through space and bombard atom 2. And the same would apply to atom 2. But in such a scheme, all atoms would disintegrate and grow smaller over time, which does not happen. And even if particles did disintegrate and bombard neighboring atoms, each would simply be pushed away by the onslaught of particles not drawn together, which leaves just one possibility. Each atom must give off some form of energy that travels through space to draw neighboring atoms together. Okay, that paragraph is key because the idea is the atom has to give off either matter or energy for it to attract other atoms to it. Now, according to the standard model, that is where they come up with the theory of dark energy and dark matter. This dark matter is supposed to be the glue that holds everything together. You see what I'm saying? Because if they were to say that it's energy that's bringing everything together, they would have to acknowledge that intelligent design. And like I say, that is what they do not want to get into in modern science. Because if they do, it all goes back to the ancient principles. So let's keep going. As far as we know, the only form of energy capable of traveling through space is electromagnetic energy, radio waves, which means that gravitational mechanism, however it may work, requires that all atoms radiate radio waves. But each radio wave is known to comprise of two distinct waves, an electric wave and a magnetic wave, figure 3, that moves through space at 90 degrees to each other. With this in mind, it is at first difficult to see how two items might be drawn together by such an arrangement, and yet our reasoning assures us that this must be the case. So what kind of radio wave radiating from an atom might be capable of drawing a neighboring atom towards itself? Okay, so you see the idea is that the atom gives off electromagnetic energy. Now, the point is that it has to give off a certain type of a pattern for it to draw other atoms closer to it. So he goes on to bring up this Archimedes screw in his early form of water pump, right? And he's talking about figure 4. And earlier he was talking about figure 3. So let's go here so you can see what we're talking about here. So 3, he was talking about electromagnetic waves, okay, what we call radio waves, microwaves, X-rays, anything with a rays is just electromagnetic energy. That's all we always talking about, just different frequencies of the electromagnetic spectrum. So the way that the energy travels is the electric wave is always 90 degrees to the magnetic wave. That is key to reality right there. Okay, just keep that in mind for future videos. But I'm gonna bring it's gonna be a central theme. So anyway, knowing this, his example is the Archimedes screw. Like I said, this water pump that's designed to, as you can see, it turns and then it brings the water up, right? So his idea is that the atom gives off these electromagnetic waves in a corkscrew style electromagnetic radiation. Okay, so that's how they attract each other. And remember, his point is to present a different way in which gravity works. Okay, because we already know what we call gravity now is simply a math problem to describe an observation. He's trying to understand how it actually works. Okay, this is real science. That's why this book is called Future Science. So I'm gonna keep going. I'll let you read that if you like, but we're gonna go to the next page. When he said it pulls water towards itself. This suggests that if atoms radiate corkscrew style radio waves like those illustrated in figure 5, then they might be pulled towards each other. The tubular style wave would, however, require slight modification to comply with Newton's observation that the force decreases in proportion to the distance squared. Figure 6b shows the tubular wave adjusted, diverging as it radiates away from the atom, and figure 6c explains why the electromagnetic force in such a scheme decreases per meter squared in proportion to the distance traveled. In just a few moments of reasoning, we have conjured a theoretical force that might act on neighboring atoms and draw them to the source of radiation, one that fits in with the demands of Newton's equation. We must now look for a mechanism that shows how fundamental matter might radiate corkscrew-style radio waves. But firstly, we need to look at fundamental matter. All right, so I'm gonna stop it right here, so you just get that idea, okay? That the atom in itself puts forth electromagnetic energy, and that is what we call gravity. All right. So next video we're gonna go into a new look at matter, and we're gonna break down the atom. We're gonna keep reading, but just so but lastly, I want to show you this picture just so you can really understand what it's saying. I put it on there. So the corkscrew style radio wave, right? But as it travels, it spreads out. So then it gets weaker. So that's how, the force, the theoretical atom radiating gravity adjusted, accommodated for Newton's observation that the force decreases in proportion to distance traveled. There we go. Okay, so there you go. So that's what he's talking about. The rate in which it goes out, essentially it just spreads. It's just another form of entropy, as something goes on disarray, So as theoretical gravity waves radiate from atoms, they must decrease in field strength per meter squared for every unit of distance traveled. The radiated energy diverges geometrically and thus reduces by square of the distance traveled, d2. Italicized numbers inside the boxes show the field strength of the radiating electromagnetic energy in volts per meter squared. Squares are used here to schematically illustrate the principle. The diverging wave is actually conically helical, as in B. Let's see, where is B? Oh, okay, conically. Okay, that's what he's saying. So he's saying using squares here just to show the math, but in actual it's more of a cone shape. Okay, so there you go. In the next video, we're gonna go into the atom. Peace.